So I'm going to talk a little bit about what SAP has, so I'm going to be a little more overt in an advertisement for SAP than perhaps our first speaker was, but because it's really relevant about what we're doing, how we're actually managing big data. Then I'll talk about some of the solutions we have, and then really where I wanted to get to, and matching the title, is get to some use cases from our customers to talk about the so what, which I really love, by the way. So what? Where's the value proposition? So that really is ultimately the objective at the end. I like to use these pictures, this picture or some pictures like this, because interestingly enough, when I talk about big data, this is the life in the past. Those cars going by, we can't see them. So in most data warehouse environments, what you get is the pattern. You don't actually see the cars, you see the pattern. And so really, where we are today with big data and the capabilities we have and other companies have is the ability to stop that picture and actually see the individual taillights and the cars and the people inside the cars and what they're eating and what they're talking, what they're listening to on the radio. That's the capability we have that we didn't have in the past. So, start a little bit about SAP, and I know, I appreciate that you saying, of course it's SAP, but interestingly enough, we didn't show up on some of the previous slides. So I think SAP is one of the best kept secrets on the planet. We do have almost 200,000 businesses running SAP software. We operate ourselves in 120 countries. We focus on and divide our business lines on 24 industries. I focus exclusively on retail, but I think you'll see as we talk through retail, this is for the people in the retail school, retail is not what retail used to be. Retail is everywhere. So some of my examples you're going to see wouldn't be considered retail, but they're actually selling products to people and generating revenue. That's really the essence of retail. We do have 65,000 employees, and it grows continually. And the other key point is 63% of the world's transactions actually touch an SAP system. And that actually is material for what I'm going to talk about again in terms of the HANA as we look forward at our capabilities. If you shift into retail, which is where I live, almost 12,000 retailers in 114 countries use an SAP solution, one or more of our SAP solutions. And translating that, 86% of the retailers in the Forbes 2000 are SAP customers. So SAP is everywhere, including in Scottsdale. So this is for the people in the retail and the data scientist team. We have a center of excellence for data science and retail in Scottsdale, in our lab. Tom actually, not that Tom's a data scientist by any means, but Tom actually is located in that location. We have 17 scientists with advanced degrees. We have a huge HANA instance there, and we're actually very happy to have a HANA instance here now at the school, so really pleased to have that up and running. On those instances, huge power behind it with a huge amount of data to play with for these people to try out their algorithms, et cetera, to work on our systems. So, jumping into the revolution that is HANA. HANA is an in-memory computing engine, so the revolution is that we took the data off the disk and put it in memory. It all sits in the memory, in main memory. So for the geeks in the crowd, I try and avoid being a geek, sometimes I can't help it. But no longer are you going through the I/O bus to get to the data. You're accessing it from main memory. So of course that's orders of magnitude faster. We put everything together. It is, as mentioned previously in one of the sessions, it is horizontally scalable, so you just plug multiple nodes together so you can expand out to almost infinite or virtually infinite. I'll talk a little bit about the practicalities there. But on top of which, we also created a calculation and planning engine in the database tier. So again, for the geeks in the crowd, we don't have to take the data, do that big extract out into the application tier, do the calculation. We actually do the calculation in the database. And of course, that has evolved and dramatically evolved with SQL and embedded SQL over the years, but this now takes it to a new level. So, again, it is an in-memory database. It is row and column based. The primary use is columnar. So again, what that means, we have huge performance gains as we do analytic type operations. But there is also the capability of doing row store. So all of this is wrapped up in something that looks suspiciously like a database, so that it actually works with existing applications as well. So that's a key motivator for us. again, so looking at it, we actually worked in the original design with Intel. So this is based on an Intel chipset, but that chipset is actually delivered by 10 to 15 different, all the major hardware manufacturers. So including our friends at IBM. So again, it is available as a commercial product, and there are, we like to encourage competition because that's good for our customers, right? So our hardware partners get to compete for our customer base. We have seen accelerations into the order of 1 million times for analytic operations. It's absolutely astounding, the capabilities and the benefits that come across. It is columnar, so we do have fast store. The columnar also means that we can do much better compression. So again, the data that historically, when we had big data, we can usually get down to about 5 times compression of that data. So again, it means it's less big data. Because we can do partitioning and we can actually have horizontal scalability, there is really no limit. And we have huge examples. In fact, we built a petabyte farm with HANA ourselves and run that. A key dimension is that we do not do aggregates. So it's related to the discussion that was happening before from Brenda around, really, historically, what you got out of a database was predefined, certainly a data warehouse environment. It was predefined by the dimensions and the indices that were defined up front. Effectively, the developers decided what the business people could see. So a key example was from one of our major customers. It's the 30th largest retailer on the planet. The CIO said, historically, my business could never understand why it cost $1 million and took 3 months to get a report. And that was because most or all of that time was actually finding the data, moving the data, getting it ready to run the report. It wasn't actually creating the report. It was getting the data in place to get that report. The other statement that came from that same customer was that in their historical legacy Teradata instance, they had 8 different aggregated copies of sales data, POS data, because each organization was looking at I need this, I need it in this structure, in these dimensions, that's what I need. So they just built it their own. So it goes to these silos that were mentioned, and definitely we can confirm that that's really the life in retail, is these silos are everywhere. It is real-time replication, and it is in insert-only delta, so again, in HANA, we never change a record, we just write a new one at the bottom. So what does that mean? Combine what I just described in terms of the HANA architecture with the facts that were presented about SAP running a big chunk of the world's business, government, commerce, all of it runs on SAP. If you look at the old way, and this was emphasized, I think there was different representations, but we're talking about the same thing. The old way, you have something running on the operational data store, you do an ETL, you pull that out, you put that into the data warehouse as part of that ETL, you're making some aggregations and you're creating the indices, then you put some analytics on top, and finally you can see an answer. That answer for the business is usually days or weeks after the fact. Days or weeks, in some cases multiple weeks after the fact. Where the way we look at HANA is, there is none of that. You do analytics directly on the operational data store. So in effect, when we started with HANA, the journey started with looking at the traditional environment, the blue one, saying, how can we fix that? And instead of saying, how can we make a better data warehouse, the statement was, how do we not have a data warehouse at all? And eliminate that tier and look at things by basically running on the operational data store. So it was very much a radical concept, and we have executed, and now we have hundreds of customers running this, and there'll be hundreds a month or hundreds a quarter going, because we have very rapid adoption of this globally. The other interesting thing, so if you look at this now, that means I can do analytics on the operational data store. I can see what's happening right now. The other significant advance, if you want to call it that, however you want to phrase it, is around the fact, so now we went from being able to see what happened. It happens here, and I can see about it here. If we're doing the operational data store, we can see it more or less at the same time. But in effect, if we apply on top of that the predictive analytics, we can now see or predict what will happen before it happens, or make a prediction. So we have also built into HANA specifically a predictive analytics infrastructure. So built right into the core of HANA is a predictive analytics library. And for the data scientists in the room, I'm not a data scientist, so those are the algorithms that we have in there. There are more there. But I would also say that we want you as well to come work for us. And we'll talk a little bit more about that at the end. But that's a key part for our company. A key dimension of what we're aiming for is how do we use this data, not just to report on what's going on, but how do we make predictions about what will happen in the future intelligently. We also have, for the data scientists, we have an R integration built in into the HANA engine so that the data scientists can use the native language, that open source language, and build whatever algorithmic enhancements they want. And of course, we do have a data pre-processing and loading tier that it comes with the system, and we have already pre-built integration with Hadoop and other types of large data sources, and also the ugly, ugly world of retail. I would disagree with Brenda. POS data is not pretty. It's not clean, unfortunately, having dealt with it for too long. It's structured and well-structured, but not clean, unfortunately. So there is a lot of work that has to be done in retail to clean that data, to make it usable. But it is a key, obviously a key focus for us. If we switch now to retail, so that's our sort of our technical underpinnings. If you look today, this I think is very much aligned with what was described earlier. This is the situation today in retail. We have all of these channels evolving for our customers, and often these channels evolve independently. Again, it was the norm in the 90s, those early adopters of Web Channel was to set it up as a separate company, Walmart.com. It was the norm, it was the best practice theoretically, which of course evolved into these things running completely independently. And we see most retailers today are doing exactly the same thing. The stock for the e-commerce site is in a specific DC, maybe the same DC, but separated by a wall. This is the inventory for the Web Channel, this is what goes to the stores. Which means when that inventory on the Web Channel runs out, sorry, you can't buy it, except that there may be thousands of them sitting on shelves in a store. But the web shop will say, we don't have any because my inventory that was dedicated to the web shop is not there. Likewise, the mobile applications are almost, the first generation of mobile applications were almost always put out by the marketing group with no thought of what any of the other organizations. They just went ahead, they engaged a small organization and built a mobile app, shipped it out the door to the consumer. Great, we're now rocking. Which of course meant that it was quite possible for the marketing team to put out a promotion on a mobile app, the merchandising team to make a promotion that's delivered through a flyer or something else, and nobody tell the supply chain team that they should actually have enough products there to fulfill what was going to happen. And that, of course, leads to the second image there, which is really, and it goes back to the statement about from the CIO that he had 8 instances of store data, right? And in most retail organizations, the fact of life is each of the organizations has their own set of data. So when the C-level executives show up in the boardroom, they each have, unfortunately in many cases, reams of paper with different numbers. For the same business, but different numbers. How many products did we move last week? This person has one number, this person has another number. And that's really the fact, the state of the art, unfortunately. There are many retailers that are better, but the bulk of retailers are living in this world. And likewise, we have a supply chain that is really combative in many cases. The retailers don't share data with the suppliers and the retailers are really trying to fight each other to say, how do I get the best deal for myself? And in most cases, we're both losing. So the objective we see our customers are aiming for, we're aiming to help them get there, is really to redefine that customer interaction. So there is that seamless, omni, multi, no channel, channel-less, take your phrase, I don't really care what it is. It's the one where the customer feels the same on all channels. Again, it's horrendous, some of the things we see in the real world, that the customer master for the web shop has nothing to do with the loyalty program, or they have some sort of arm's length relationship that every now and then they try and sync up. And really, we should have a single experience. And we know from a shopper experience, the shoppers are, all of us have a number, whatever that number is, we're going to do some research. So many dollars, we say, yeah, above that I probably should check it out, you know. I should go online, get some stats, I should go into the social domain and get some reviews. I may very well want to go to the store and pick it up and touch it and feel it, press the buttons, try it on, whatever that might be. But the path to purchase goes through all of them. So how can the experience be different across those channels, that it just doesn't provide a positive customer experience? And of course, when we look at all these different organizations, they need to see the same data, they need to see it in real time, and it really should be customer focused. I saw that picture earlier, I think it was the Macy's one, and that we definitely agree with. Retail historically was about product. It was the item that was, and our systems were designed all around the item. The item was the center, and everything revolved around that. The item, then we had assortments, then we had pallets of that item moving from the DC. But really, as we look at the world, we have to think from our system perspective for retail that everything should be customer centric. Really, that should be the center. So if I look at assortment planning, what set of products should go in that store, it shouldn't be, I only have so much space, so I'll take the top 4 products in that category and that's what I can fit. It really should be, what kind of shoppers are shopping at that store? And then figure out from that which products should go in that store. It will still be 4 products because the physical world is like that, but it may very well be the different set of 4 products in that category that end up in that store if you look at it differently. And certainly the channels, you know, can we work? Okay, I have to move along very quickly then. Can we work through these different channels and be more collaborative? Can we get ship from vendor, ship from store, all of these different channels? So again, we're looking at this, that blue circle is the big data, right? It has to be all together. It has to be at the detailed level for all of the organizations, and they all have to work off the same thing. So looking at this, I'm going to blow through these fairly quickly. Another key message I wanted to point out is that big data is not just for customer. I mean, I think that's one of the myths I'd add from a retail perspective. In most cases, the most retailers look at big data and say, if I can get it all together, I can do great things for my customer. Which is true, and there's no denying that there's a significant value there. That we can understand the customer better, we can make offers to those customers. But there is significant benefit that we can show looking at the supply chain as an example, or looking at merchandising and supply chain. An interesting example we have is our on-shelf availability. So retailers have been doing forecasts for many years. It's still surprising how many don't do any sort of statistical forecast. They're simply spreadsheets from this is what we sold last year. But assuming they can get to that, we have a solution that takes that, breaks it to an intraday forecast, and then monitors sales in real time. So it works for fast-moving products and says, it doesn't really matter what your inventory system says. If you haven't sold 6 cans of Campbell's tomato soup by noon, it's likely they're not on the shelf. It doesn't really matter if your inventory says you have 2 pallets or that's not material. The material fact is customers haven't bought it. So it's likely there's something wrong. But it builds on that forecast that is the fundamental predictive analytics for retail. And that is the basis, and the baseline is forecasting. So I wanted to jump into some customer examples. Home Shopping Europe is very similar to QVC, Home Shopping Network. They have a television ad, they have web shops, but it's about timed promotions. So again, I want to emphasize one of the messages, yes, it's about getting more data and using more data in a more effective way, but it's also about reducing the time lag from when the data happens to when we can use it. So in this case, these are, you know, many of you I know have seen, whether maybe at late night or not, but you see the little counter coming down, counting down. So there's 2 dimensions. One is that Home Shopping Network is looking at dynamically adjusting how much time they give to a product slot on the television based on sales and other predictive mechanisms. But then at the back end, they have support for the call center, so when the person calls in, they're also able to do upsell and cross-sell based on predictive analytics as well, based on all the customer data that they have in their hands. Big Point is an interesting one. This is also a gaming environment. And I wanted to put this in because it was for our retail colleagues here to recognize retail happens everywhere. So with that, I wanted to show a short video. It is 2 minutes.
Big Point is one of the world's largest video game developers. We make browser games. This means you can play our games online anytime and any place. We have a user community of around 300 million users, and it grows by 150 to 200,000 users every day. Our games can be played online for free. This means that thousands of players can be playing the same game at a given time. What we do is sell virtual goods. For example, we might sell a boat or a special sail, or a special sword in a pirate game, or we sell special colors, things like that. Our industry depends on speed. We want to know in real time what people are doing in our games. When users are online, we have to be able to provide them with customized offers.
Ein maßgeschneidertes Angebot machen. Also wir haben das Thema Real-Time Monitoring.
We have real-time monitoring, we have real-time analyzing, and we have real-time offering. Bringing all of this together is the challenge we are faced with. So we approached the SAP Innovation Center in Potsdam with this issue. We said, we have so much data and we don't know what to do with all this data in real time. And SAP said, we've got something for you. It's called HANA.
Das heißt HANA.
Die technologischen Herausforderungen.
The technological challenges at BigPoint are posed mainly by the sheer amount of data we have. The thousands of data sets that are generated every second in various areas and systems at BigPoint.
In unterschiedlichen Bereichen, in unterschiedlichen Systemen.
HANA was a suitable instrument for us to address this problem that we identified. Of course, we first had to understand which analyses are important. What are the key figures that we have until now, seen on a level of 24-hour periods? What is the added value if you can calculate this in a matter of seconds?
In Sekundenschnelle berechnen können.
Konkret haben wir die
We now have the possibility to see in real time what is happening in the games. That is the first and foremost requirement for us, and up to now, we had no means of achieving this. In the past, we had delays of 6 to 24 hours. Today, we have not 6 seconds, not 6 milliseconds, but real time.
Grundsätzlich ist es für BigPoint.
Basically, it is interesting for BigPoint to identify user groups and categorize them according to specific criteria, such as their buying history or their behavior in the game, say in the last 15 minutes, and to use these user groups to offer products to them and see whether they respond to them.
Spricht diese Benutzergruppe auf das Angebot an?
unsere Erwartungshaltung und die
Our expectation, and it actually seems to be coming true, is that the use of this technology and the methods behind it helps us realize sales growth spurts of 10 to 30%. This, of course, is fantastic.
und das ist natürlich fantastisch.
Die Lösungen,
The solutions, projects, and prototypes we work on at the Innovation Center are pioneer
das
projects.
sind Vorreiterprojekte.
The things we can do now, which we were unable to do before, that is, reacting to players in real time and operating in real time, are a real revolution considering the amount of data that is generated in the game industry, mainly at BigPoint, with their 300 million users.
Millionen Spieler, die sie haben.
I am very pleased with the result. It exceeds all the expectations we had initially. We see that there is still a lot of potential and that this is just the beginning.
Ganz am Anfang steht.
Geschwindigkeit ist alles.
Speed is everything, and in this respect, HANA gives us excellent support.
So I want to emphasize, we talk a lot about, speeds and feeds, seconds and milliseconds, but the key number in there was 5 to 10%, right? Sales improve. That's the so what, right? The so what. They've sold more. And that's real revenue. That's not fake money. That's real revenue. Media Saturn. I wanted to show you this one. It's a solution that we have with a partner that's based on HANA, but it's for buying. It's for the buyers to simulate conditions. So again, this is way up at the supply chain for a buyer. A lot of the challenges in retail, you hear the common one around Amazon and showrooming, means it's very difficult to compete on price. So if you look at the bottom, lowering the price of goods by 1% has the same impact as increase of sales by 18%. There is margin to be made in retail on the supply chain. It's much more difficult to compete on the sales side. Yes, there are ways to do it. There are ways to increase frequency and recency and basket size, but we should not ignore the rest of the business environment to make that money. Liverpool, another area in supply chain. In this case, it's inventory management. The benefit that Liverpool found was releasing capital. Because if you look at retailers, they're two largest controllable expense are inventory and human capital. So they have a lot of money tied up in inventory. Liverpool is a huge department store, the largest one in Mexico. So like our friends at Macy's, very, very broad assortment, exceptionally large. So in their case, it's around 900,000 items, active items. The challenge they have is identifying which of those 900,000 items are not selling and in which locations, and what can we do about it? Because if they're waiting days or weeks to get information back, that product's sitting on the shelf, it's not going anywhere. Then they look at markdowns, et cetera, and that kills their margin. So in this case, they're able to look at the products that are slow selling and non-selling, stop them coming in the back end to the DC, and redirect them and literally move them from one store that's not selling to another store that is, and make more effective use of inventory. And that's a key trend in retail, is how do I make more effective use of inventory? That goes to fulfilling from stores, et cetera, et cetera. But all of that is, how do I make more effective use of that inventory? T-Mobile is a classic sales analysis, customer engagement story, but I also wanted to emphasize retail is everywhere. This is the T-Mobile stores where they're selling plans in conjunction with handsets, and they were offering promotions, and they wanted to get better feedback on those promotions and understand in detail what's happening, which promotions are consumers responding to, which ones are they not, should they change the promotion mix to enforce the ones that are working and stop the ones that aren't. So I'm not going to show the video on that one because we don't have time. But just a couple of real life lessons, and again, confirm with my friend, garbage in, garbage out. I like to think I'm younger than I look, or older than I look, I'll get it that way, but garbage in, garbage out was there from day one, it remains, right? The challenge is data. Yes, we can deal with unstructured data, so this isn't talking about unstructured data, the fact that it doesn't have a structure. The fact is data is incomplete in some cases. Some systems are not as rigorous as they should be in terms of making sure the data is accurate, et cetera, et cetera. And again, sales data, POS sales data coming in from multiple locations. If we have a multinational retailer, they will have multiple POS systems. In fact, I started in retail and point of sale, so I know all about this. Lived through this too many times. That it is a significant challenge. And of course, sales data is the foundation of the retail forecast. Of course, we then factor in all of these influencing factors that would change history. I mean, if it was just exactly what we sold last October 28th, it would be not that exciting, but it's really not. It's about what we sold then plus all of the factors that happen and will happen. The fact is, and this I think was mentioned previously too, often retailers have a heterogeneous environment and you have to reconcile the data from multiple systems to get it to a point where you have a single clean set of data. So master data management was mentioned by Macy's. I know of retailers that have multiple master data systems, and we have to somehow manage that all together so that when we look at the sales data, we know what we're talking about. Partitioning, we can scale it out. There is still hard work in big data. It's not, the PowerPoints make it look easy, but unfortunately, life is a little more complicated. So partitioning, managing those scale out nodes, managing which data you put on which nodes, et cetera, it is still a challenge. Hopefully in the future, technologies will evolve and we can spend less time on the mechanics and more time understanding it. Interestingly enough, need to hide the science, and I think this was mentioned earlier too. Put the tools in the hands of the end user. So again, if we're storing the data at the lowest level of detail, we don't need IT to be involved to be the bottleneck. Really, it should go out into the business domains and say, they should be the ones defining. If they want to look across everything we've ever sold and see what's kind of, the products that are blue, then go ahead and do that. We do not have to have aggregations and indices on that particular dimension. The other thing that's interesting that we've learned as we've gone through our evolution with our customers is if you change the order of magnitude of time to execute a business process, so if you're changing it radically, not just saying, okay, I can do it 25% faster, but if it becomes something that was a 24-hour process that now is a 24-second process, the users will interact with the systems differently. They won't be so afraid to try different scenarios and say, well, what happens if I did this? Because if it's a 24 hours, it's going to suck up systems, and they're going to make sure everything's lined up and then press the button, and that's what's going to happen. So there is a human dimension that goes with this as well. So with that, I will close and show you that we are also, we are interested in data geeks. I don't claim to be one, but I like them anyway. We have a big data challenge. So please, this is one way if someone, to answer your question ahead of time, we want people to join. This is one way to get visibility into SAP. And also, hey, you can, your school or your group or your individual, as an individual, you can make some money, get a trip to our tech ed, et cetera, et cetera. This will continue. It's fairly late in the year right now, but hey, there is always time. But nonetheless, encourage the teams to go take a look at the big data site and the challenge there. And also the SAP HANA Academy, I know you have it here, but also, again, to answer the question, okay, for the data scientists, you will have a much better time through the employment processes at SAP if you have some understanding of HANA. So with that, I will close and open it for questions.